Hi friends, welcome to everyone. In this video, you can understand principle of operation of a CNC machine. If you like this video, like, comment, share, and subscribe. Okay, we go to the topic. Sketch of a numerically controlled machine tool. Principle of operation of a computer numerical controlled machine, CNC. The CNC machine differs from a conventional manual machine in several respects. The principle of operation of a numerical controlled machine can be explained with the help of figure. The above figure shows a vertical milling machine. For carrying out an operation, like end milling, the spindle head is to be positioned in Z axis, and the table in X and a coordinate axis. The feed movement is to be realized by the individual, or simultaneous movement of X and Y axis. Thus the milling machine requires 3 slide movements, which are usually referred as axis feed drives. A special feature of a CNC machine is that a separate motor called a servo motor individually drives each axis. AC servo motors are the preferred choice for this purpose today. DC servo motors were widely used earlier. The slides are driven by the servo motors through recirculating ball screw and nut assemblies. The use of recirculating ball screw reduces friction, backlash, and wear. The low friction reduces the torque required at the motor and the lost motion through torsional deflection of the screw. The use of ball screws also improves the dynamic response of the system. In some modern designs, particularly in the case of high-speed machines, linear motors are used in the place of servo motor ball screw combination. In order to carry out the milling operation on the workpiece, the coordinate information, X and Y coordinates, of the starting point and the ending point, has to be coded in the NC program. Similarly, the information regarding the direction of rotation and speed of the spindle, use of coolant, and the feed rate is also coded suitably. The CNC controller decodes the positioning information coded in the NC program, and the slide is moved to the programmed position at the required feed rate. Each slide is fitted with a feedback transducer, which continuously monitors the slide position and compares with the programmed position, as well as the feed rate. The feedback transducer is mounted either on the slide or on the servo motor and measures the displacement or position of the slide. For example, let us assume that a hole is to be drilled at the location x equals 100.0 and y equals 150.0. The corresponding block of the program is read by the control system, and the necessary inputs are sent to the x and y-axis servo motors. These motors drive the respective slides to the commanded position. When the distance information from the feedback devices equals the programmed values, the slide movement stops. The input is then given to the z-axis servo motor to perform the drilling operation. The system switches on the motor driving the spindle carrying the drill, and commands the z-axis servo motor to move at the programmed feed rate into the workpiece till the programmed depth is reached. The z-axis feedback transducer ensures the correct depth and feed rate. The drill is then withdrawn to the desired height, and the machine starts the positioning movements to the next location of the drill. This procedure thus ensures production of accurate work pieces. The feedback transducer used may be analog, synchro resolver, or digital encoders. Another classification of feedback transducer is based on their nature of measurement, absolute or incremental. They are also classified as linear or rotary, depending upon their construction. Linear feedback devices include optical scales, inductacin, etc. Rotary feedback devices are mounted, either on the ball screw, or, on the motor shaft, and measure the slide position indirectly. Rotary encoders, optical scales, and synchro resolvers are the commonly used rotary feedback devices. The measured and the targeted positions are compared, and the servo system ensures that the correct positioning is achieved. To make this error zero, difference between targeted and measured positions. The resolution of axis feed drive is usually 1 micrometer. Since positioning is done electronically, it is possible to achieve accuracy and repeatability of the order of 5 to 10 micrometers, even under heavy-duty cutting conditions. 2 servo loops are incorporated in feed drive, one for the position, and the other for the feed. In addition to this, the selection of spindle speed is also under servo control. Do you want more videos about mechanical engineering? Like, comment, share, and subscribe.